Okay, so now let us start with our next two topics. The first one is Nernst equation, and the second one will be calculation of equilibrium constant from Nernst equation. Okay, so when is Nernst equation required? Nernst equation is required whenever we want to calculate electrode potential, but we don't have those standard condition, which were concentration should be 1 molar and pressure should be 1 bar and temperature should be 298 Kelvin. Okay, so if either of the three is not being satisfied or two are not being satisfied, so we use Nernst equation. So Nernst equation में आप cell potential will be depending on temperature, then concentration of solute, partial pressure of gas, and so on. So now for getting our Nernst equation, we will be using Gibbs free energy formula from thermodynamics. That was delta G will be equals to delta G naught plus RT natural log Q, right? So here delta G will be the Gibbs free energy at some certain conditions, and delta G naught will be the Gibbs free energy at the standard conditions. Okay, and RT natural log Q. Okay, so वो हमें पता ही है. Now from the formula G is equals to minus NF E cell, we will be giving a new equation that will be minus NF E cell will be equals to minus NF E naught cell. Okay, so E cell will be the electrode potential at the given conditions, and E naught cell will be the electrode potential, the standard electrode potential, that is had those standard necessary conditions. Okay, so here we can also write the natural log Q in the form of 2.303 RT log Q. Okay, so if we put on like NF को हम divide कर देते हैं entire equation को, so we will get E cell will be equals to E naught cell minus 2.303 RT upon NF log Q. Okay, further if we put on T is equals to 298 and R will be equals to 8.314 joule per Kelvin per mole, and F as 96500 calories. So we will be getting a new equation that will be E cell is equals to E naught cell minus 0.059 divided by N. Okay, so N will be the number of transferred electrons and log Q, and Q will be the reaction quotient. Okay, so from where did 0.059 came from? The we get the numerical values of R, T and F. Okay, so the entire equation is all right now. Okay, if we say that our cell is in equilibrium, so we must say that delta G, that is minus NF E cell, will be 0. So therefore आपका जो E naught cell होगा that will be equal to 0.059 upon L log Q. Simple as that. Yeah, so we will be concluding if we want to calculate Q or K equivalent, right, reaction quotient or equilibrium constant. Now that reaction constant should be called equilibrium constant because we are taking a special case in case we are having the cell at equilibrium. So G naught and delta G will be 0. So therefore delta G naught will be equals to minus F E naught cell. Okay, and we can also say that minus E naught cell is equals to 0.059 upon N log Q. Okay, or KE. Now log KE will be equals to NF divided by 2.303 RT E naught cell. Okay, pretty simple. The log Q at the left hand side, NF going upwards towards the right hand side, 2.303 RT downwards towards the right hand side, and E naught set multiplied. Okay, and now again putting R and T's value, T as 298 and R as 8.314 joule mole Kelvin, we will get log K will be equals to N upon 0.059 multiplied by E naught cell. Simple as that. Also, we can say that if we don't want a log k equation, if we want k equivalent, so we can also write as k equivalent will be equals to 10 raised to the power n, where n will be the number of transfer electron. E naught cell divided by 0.059. Okay. So now if we revise fastly from the intro part, so we will be dealing with, like in this particular chapter we are dealing with electrical energy and chemical energy's relationship between each other. Firstly we studied about electrochemical cells, and now in the next audios we are going to study about electrolysis or the electrolytic cells. Okay, and then the last audios will be of batteries and fuels, right? So we first read about the working principle and construction of cell, that is electrochemical cell, two cells, two half cells, beakers, then salt bridge, electrolyte, anode, cathode. These all things were pretty simple. Then Daniell cell will be the cell, instead of salt bridge there will be a porous pot or porous diaphragm, but it is a type of electrochemical cell. Then we dealt with the shorthand notations for galvanic cells, right? And double dash for salt bridge, simple dashes for separating two phases of state of matters, right? Then we also seek the difference between electrochemical cells and electrolytic cells, a detailed difference, right? Then we came to electrode potentials, and then the factors depending it upon oxidation potential, reduction potential, and then we came to SHE, that is standard electrode potential, right? How to calculate EMF, electromotive force or cell potential, and then the free energy change for a cell reaction, from where we got the formula delta G will be equals to minus NFE. Electrochemical series, learned it by using tricks also and mugging up also. Then coming next, we learned in this particular video only, the audio only, that Nernst equation and calculation of equilibrium constant from Nernst equation. Okay, so electrolysis in next audios. It will be fun. Bye.